Good morning, all of you. So, as we know, presently we are going to discuss Newton's laws of motion. So, Newton has given three laws. So, to describe the motion of a body, that is what to give the relationship between force and as well as motion. So, Newton's laws of motion. So, totally, how many laws we have? How many laws we have? Three laws. So in today's class, we are going to study the first law, that is what? Newton's first law of motion. So also we can call it as, in last class I told you, Newton's first law of motion also called as what? Galileo Law of Inertia. Do you understand? That is what we have been learned in the last class. So yesterday we have been done the Galileo's experiment for the inclined planes. Do you remember, guys? Yes, sir. So we made one final conclusion. Can anyone tell me the final conclusion? Please respond. Newton's first law of motion. All of you keep reading. Newton's first law of motion. Now, actually, Newton has got the idea and he has made this concept, Newton's first law of motion, from Galileo's conclusions only. That is what I'm asking. Can anybody give the Galileo's conclusion? What is the final conclusion made by the Galileo, what we studied in the last class? Please try to communicate and answer. Anyone, please? Girls? Yes, please. Yeah. No issues, you can speak. Anyone?
Sir?
Yeah, please.
Sir, if there is no external force, the body which is in rest will remain rest, sir. And the body which is in uniform motion, it will keep on moving, sir.
That is what? It is what the conclusion we made from the Galileo's inclined plane experiment. Is it yes, guys? Yes, please respond. Daniskar? And I told you to do the inclined experiment. Have you did it, guys? Please respond, everybody. Anybody, have you tried with your brother or sister in your home? Thus, of course, if you have not been tried, today after reaching home, you have please try. Now you can see the same conclusion which we have been made from the Galileo, the same thing Newton has taken and he framed the same statement again. That is what? Newton's first law of motion. So you all people know already what is Newton's first law of motion. What is Newton's first law of motion? Anybody? Please respond. A body is at rest, will remain at rest, and a body is in motion, will continue in motion in a straight line. With what speed? In a straight line with what speed, guys? With the uniform speed. That is what? With the uniform speed, unless when? Unless it is compelled by an external force. Understand, guys? So unless if you are applying the external force, the body which is in state of rest, suppose I kept one water bottle here, let me take, or else I kept one box here. Now, today I will see, tomorrow I will see, day after tomorrow I will see. Unless some person will come and will push, is it possible to move this box? Is it possible to move this box by itself? Please respond. Anybody?
No, sir.
No. So that is what? So the box which is in rest remains in state of rest. Now, let me take one ball. Now the ball is started moving. Now, the ball which is in moving in a uniform motion, in which line? In a straight line, always will be remains in uniform motion unless and it is compelled by an external force. What do you mean by compelled? Anybody? What do you mean by compelled, guys? Anyone? It is compelled by an external force. Now, I will ask you one question. If the ball is rolling on the ground, nobody is stopping, but after traveling certain distance, finally it will stop. Why, guys? Here, what is the external force is acting? Anybody can tell? Girls, what happened? Mitaksri, Agilan, try to open your mouth to communicate with me. That is what I want. Kaushik, what happened? Who is applying the force? How the ball is coming to rest automatically, even though nobody is trying to hold it? Why? So somebody is exerting external force, which all people know that already. Very good. Who said that? Who said that? Yeah. Very good, Akilan. So, ground is exerting friction. This ground is exerting what? It is exerting friction, and also one more is exerting, which is invisible to us, but it is present everywhere. What is that?
Gravitational.
Air. Understand, Hari? Air resistance also. So this air resistance and as well as gravitational, that is what ground friction is exerting. That is what external force we can say. So this external force only make the ball to stop after traveling certain distances. Is it okay, everybody? Gokul, Harish, Danishkar not speaking means I'm not at all interested. I'm saying you very seriously. That is what is happening. So that is only called as Newton's. For example, no friction exerted by the ground, no air resistance. Now, is it the ball will come to rest? That is what my question. Anybody can answer? If there is no,
sir.
if there is no air resistance, if there is no the friction exerted by the ground, is it the ball will come to rest? That is what I'm asking.
No, sir.
No, it will be continuously roaming on. It is continuously moving in a straight line with a uniform speed. Is it yes or no, guys? Yes, please respond. So that is only called Newton's first law of motion. So the conclusion which is made by the Galileo in his inclined plane experiment, the same thing we are studying here. The body which is in state of what? The body which is in state of rest remains in rest. The body which is in motion remains in uniform motion in a straight line. Understand? Unless when, guys? Unless an external force, it is compelled by an external force to change its state of rest or to change its uniform motion. So that is what we used to call as. Understand? So Newton's first law of motion. So something external force should be applied. Unless external force is applied, the body which is in state of rest remains in rest. The body state of in motion remains in uniform motion. Is it okay, guys? Will you understand? Yes or no, everybody? Yes, please.
Yes, sir.
Now, as I told you, to prove this experiment, let us do this one experiment to illustrate the Newton's first law of motion. As I told you, we need one transparent glass and one cardboard and as well as 1 5 rupees or any coin. I told. Is it yes, guys? So this is what illustration. What you can get. What you can say, guys? Illustration. Understand? So illustrate the Newton's first law of motion. So we need this. Three things. So hope everybody can able to see me. Yes or no, guys? Can you able to see me? Yes, please respond.
Yes,
yeah.
sir.
So this is what. So I have been taken one transparent glass. Everybody can see that. Can you able to see this glass? Yes, please. Now, this is what the experiment which we are going to do in our daily life also. Illustrate the Newton's first law of motion. Okay. Now, try to understand. I have been kept the cardboard here. What I have been done, guys? I have been kept the cardboard. Are you clear, everyone? Now, everybody, if you have, are you doing it? Do you have a glass and cardboard now, Kaushik? Yes, please. If you have, please do it. Now, take the coin. You can see this coin. Now, I kept the coin exactly under middle. Now, what is the position of the coin? Everybody can tell me. What is the position of the coin?
Top of the cardboard.
It is the state of rest. Yes or no, ready? It is the state of rest. Understand?
Yes, sir.
Now, I am trying to apply the force to this cardboard card. I am not giving the force to whom? 5 rupees coin. So, if I try to plug this card, understand, cardboard card, but what is the coin? It will be remains to maintain its state of rest only. It will be remains in state of rest. So, but when it will remove this card, it will be flip. Then what will happen? The coin will maintain the state of rest here only. So that what will happen? It will be falling. It will be falling to where? It will be falling to
Inside the cup.
Understand? So that is what we can see very clearly. So this is what we can say actually inertia, so which you can understand. That is why we can call it as Galileo Law of Inertia. Do you remember, guys? Yesterday I taught you Galileo Law of Inertia.
Yes, sir.
So try to understand this one. So I have taken a glass tumbler and placed a thick square cardboard and its mouth. Now a coin is then placed above this card in the middle. Where have been placed? In the middle. Now let us flick this card. Flick the card hard, hard with our fingers, and clicking or on flicking this card moves away, but the coin drops into the glass tumbler. Coin drops into the glass tumbler. Maybe I may be failed 1 or 2 times, but definitely we can try. Shall we try, guys, everyone? Later we'll study the explanation. Gokul, if you are having, you all people also please. Now you can see, I will try to plug that and you can notice it. Coin is fall down or not? You see, guys? Can you see inside the coin? Everyone? Yes, please.
Yes, sir.
Can you able to see the coin?
Yes, sir.
Yes.
Sir.
So what happened here? Anybody can tell me? See, I try to plug the card. Now card is here. You can notice it. Card is here. Now coin is where? Coin is there. Inside the glass.
Inside the-
Have you tried, everybody? I will give the explanation of this one. So this is what it is. Have you tried, everyone? Shall we try one more time? Of course, maybe it is failed this time, but still I'm having hope. So we'll try. But very hardly how to flicking, very hardly. Have you seen? It is fall down or not?
Yes, sir.
Yes, sir.
I understand. So this is what. Now let us discuss what is the explanation behind it. Now, initially, now you can see, initially both the card and the coin, what is the state of them? Everyone tell me. What is the state of them initially? Both
Rest,
coin and as well as card. What is the state of them? Rest or uniform motion? That is what I'm asking.
Rest.
They are in what? Rest. Now, when we hit this card with our fingers, so what is happening? The force is exiting on whom, guys? The force is exiting on whom?
Cardboard.
On card, understanding, cardboard card, so that the card, it will changes its state from rest to what? The card will get its motion. Yes or no, Hari? Yes, please respond.
Yes,
Now, I am applying the force to this card so that the card will changes its state of rest into motion. So due to that, the card moves away from the mouth of the glass tumbler. Away from the mouth of the glass tumbler. But the force of our click, however, does not act on this coin. Does not act on this coin. So the coin continues to be in which state? Anybody? Continues to be in state of rest only. That is what we used to call as inertia. Do you understand? So when the card is moves away, when the card is moves away, the coin falls into the tumbler because it prefers to maintain what state? It prefers to maintain its state of rest only. Still, so that is why we can say this is called as Newton's first law. That definition, first half of the part, the body which is in state of rest remains in state of rest only unless it is compelled by an external force. Are you clear? Hope everybody you understand this. Yes or no, guys? Try to answer my question.
Yes, sir.
This is what the first half of the definition. Definition contains two parts. One part is the body which is in state of rest remains in state of rest. The body which is in uniform motion remains in uniform motion unless they will be compelled by a what? Unless they will be compelled by an external force. Understanding? External force to change its state of rest or to change its uniform motion. Is it okay, guys? That is what we used to call as Newton's first law of motion. What we used to call? Newton's first law of motion. Clear? Now, I am using here one new word called as, you might be notice it. What is that new word called? I am using inertia. What is that? Everybody? Inertia we can call it as. Okay. So let us discuss what is this inertia. Shall we start, Hari? Everybody?
Yes, sir.
Yes. Now, observe very carefully. You are all very familiar with this. Now, it's not a new thing to us also. So, for example, can you able to see me, guys? Everyone? Yes, please respond. Mitakshri?
Yes, sir.
You need to understand a word called as inertia. What do you mean by inertia means? For example, let us take, I have given you a small toy coin. I have given you what? A small toy coin. Do you understand, everybody? Now, I will ask you to push. Will you able to push it easily, or are you feeling difficulty to push the toy car? Anybody? Yes, please respond.
Sir, can push
Easily, sir.
easily.
Yes, we can easily will push it. Even with a single finger, I can push the car. Yes or no, guys? Yes or no, guys?
sir.
Now, I have given you normal. For example, take Reddy car. Reddy is having one white car, nice, very good car. And of course, Danishkar also. Now, I will ask Danishkar to push the car. Danishkar, I have given you the same, your original car and the toy car I have given. I will ask you to push both the cars. So, which car you are feeling difficulty to push? Anybody? One toy car, one original car. Now, which car you people are feeling difficulty to push? That is what my
Original
question.
car.
Sir,
Yes, please, Taushik, Mitakshri.
Original car.
Yes, sir. The original car, of course, will feel difficulty to push. Why?
Original car.
Why it is? Anybody? Tanishkar, Gokul. Why it is difficult to push the original car, and why we are pushing easily this toy car? What is the difference?
Original car has high mass, sir.
Very good, Reddy. That is what the point I want. That is the thing, is the only thing. So, if you take the toy car, notice it, we're having a toy car is very small in size. So, it's having what? Very small, less mass. Is it yes or no, guys? Less mass. Now, if I'll take the big car, what is happening, guys? Original car, understanding a real car. So, what is happening? It is having a very, very high mass. Yes or no? Now, you tell me, if I'll try to push this car, understanding, if I'll try to push this car, now you tell me, in which state it is trying to maintain its state of, in which car it is still even remains to be state of rest, which one it will maintain its state of rest more time?
Sir, the real car.
Real car.
Real
So,
car.
real car, even though I am pushing, it is opposing my force, and it don't want to move. It is maintaining state of rest. Remains, it is trying to maintain a state of rest. When I apply more than this force, then only the car will start moving. Is it yes or no, guys? Yes, please respond. That is
Yes,
what
sir.
I am saying. So, when the body is, suppose see, Reddy is running, I am trying to stop him, but still he is trying to move. Suppose his mass is very heavy and he is very physically fit, then my force will never stop him. Yes or no, guys? Yes or no, everybody? Yes, please respond.
Yes, sir.
So why I am unable to stop the Reddy? Because he is very physically strong and as well as more mass. Now, the body, suppose I have given you one big stone, one 1 kg stone, one 25 kg stone. Which one you can people create motion easily?
1 kg
On
stone.
1 kg stone.
Why 1 kg stone? Because
Less
Have
mass.
less mass.
it cannot resist its state of rest more time. So if I'll try to push it, it will start moving. It is also will try to resist its action. It don't want to change it into motion. I want to be state of rest. It wants to be state of rest. But we are applying external force more so that it will move. But 25 kg stone, it is having more mass so that more it can resist us. Is it yes or no, Reddy? Like big car.
Yes, sir.
That is what. So that resisting capacity only to maintain its state of rest, to maintain state of motion, even though the external force is applied, that is only called as inertia. What is to call, guys? What is to call? Inertia.
Inertia.
So inertia is the resistance or opposing force which is trying to maintain its, do you understand? State of rest or state of what, guys? State of
Motion.
motion. It is the property of a body which will resist a change in state of rest or uniform motion. So the body which is in rest, it wants to be rest. The body which is in motion, it wants to be motion. So if somebody will try to apply the force, they will try to resist that somehow. That resistance is depend on one factor. What is that factor I said? That is what? Mass. So if you're having more mass, more resistance, so that I can say you have more inertia or less inertia? More inertia or less inertia? Please respond. Nobody is answering.
More inertia.
More inertia.
Inertia. Do you understand? So heavy mass, heavy, more inertia, less mass, less inertia. That is what you have to understand. Is it okay, guys? So that is what do you mean by inertia? It is a property of a body due to which it will resist a change in its state of rest or of uniform motion. That is what we used to call it as inertia. Now, for example, I will give you one football and I will give you one stone. Size may be different, but who is having more inertia? Mithakshri will say. You just wait, all of you guys. Or Vartini. Mithakshri or Vartini, you can say. I have given you one stone and I have given you one football. Now, which is having more inertia? I am asking the question.
Stone
Why stone?
have high mass than
Very
football.
good, Mithakshri. Have you understand, Mithakshri, now what is inertia concept?
Yes, sir.
That is what. So, just resisting. For example, see, general life, I will say. For example, let me take now. Daniskar is okay, funny now. Daniskar is, imagine like 500 kg. Okay, is it okay, Danishkar? Just I'm saying like describing like an object. Okay, now I will say Harish to push it. Now what Harish, Danishkar don't want to move. Do you understand? So you don't want to move forward. You might be notice it when your friends and all. Somebody is feeling shy and you are trying to push them front. Do you remember that? You're trying to hold them and you are trying to push or pull them, but still they will oppose their state of motion. Do you remember? They don't want to come front. So that is only called as inertia. So this inertia purely depend on mass. It is completely depend on mass. More inertia. Greater the mass, higher will be the inertia. Less the mass, lower will be the inertia. Is it okay, everybody? Yes, please respond. Yes? What do you mean by inertia? Single statement. Anybody? Kaushik, what do you mean by inertia? It's a property of a body due to which it will resist a change. It don't want to change. A body which is in rest, try to maintain state of rest. The body which is in uniform motion, try to maintain its uniform motion. They will oppose their change in positions. That is what we used to call as inertia. So this inertia is purely depend on what, guys? Mass. So mass is a measure of inertia of the body. Heavier objects have more inertia than lighter objects. That is what you have to remember. So that is why toy car, easily we can move. Why we can move easily? Toy car is having less inertia or more inertia?
Less inertia.
Less inertia.
If you take real car, what is happening? Real car, more
More
inertia.
inertia.
You understand? Because of more mass. That is why we have to remember, if you want to overcome the inertia, then what I have to do, Hari? Suppose I want to create a motion in a body which is in state of rest. Then what I have to do? I have to apply the force, which is what? Greater than inertia. Do you understand, everybody? So to overcome the inertia and make a body to move from rest, we have to apply an external force. That is what? Understanding. Or else, if I want to bring the body to rest, which is already in uniform motion, then also I have to apply what? Then also I have to apply external force. Do you understand? So that is why we can say Newton's first law of motion. Also we can call it as what, guys? Also we can call it as what? Galileo Law of Inertia. So that is the reason. So have you understand now how the Galileo experiment is related to Newton's first law? Same, both are same definition. Yes or no? Same definition. What the conclusion made by Galileo, Newton just simply copied his definition. Yes or no, guys? And he put a name called as Newton's first law of motion. Will you answer? Will you accept it or not? Is it true or not? Yes.
Yes, sir.
Yes, sir.
So this all the things what we studied till now, it is only related to first half of the definition. That is what? The body which is in state of rest remains in what? Remains in state of rest due to what? Due to its inertia. So if you want to overcome this inertia, then what we have to do, guys? If you want to overcome this inertia, we have to apply
External force.
External force. That is what you have to remember. Now, this is all first half of this definition. What is the second half of this definition? Anybody can tell me? What is the second half of this definition? Yes, please respond.
Motion wants to remain in motion.
Yes. The body which is in uniform motion, the body which is in uniform motion remains in state of uniform motion unless it is compelled by an external force. Now, best example I said, when you are riding the bicycle, what will happen, guys? Everybody, what will happen if there is no air resistance, if there is no ground friction, I stop pedaling, then is it possible to stop our bicycle? Is it possible to stop?
No, sir.
No.
No, sir.
Our bicycle would go on moving forever and ever and ever. It would never stop by itself. How it is coming to stop? Like a ball also, because the external force is applying. That is what? Due to the friction, due to the air resistance, or due to the brakes which were applying. So these brakes will hold the tire or wheel, it may not move forward. So that is what, if there is no air resistance and no friction to oppose the motion of any body which is in uniform motion in a straight line, then according to the first law of motion, a moving body, or moving bicycle or moving ball would go on moving forever and ever and ever. It would never stop by itself. Yes or no, Hari? Yes, please respond. Clearly understand, everyone?
Yes,
Now, let us understand. This is what the second part of the definition. Understand? The second part of the first law of motion will says that the body is in uniform motion will be continue to move unless a force compels to it change its state of uniform motion in a straight line. So unless external force is applied, the body will keep on moving in a uniform motion forever. You understand, Mitakshri, Vartani, everybody? So that is what Newton's first law of motion, the second part of the Newton's first law of motion. Hope all of you understand. Is it true, guys? Yes?
Yes.
Yes, sir.
Yeah. That is what. Now, I will make you the more real life example which we used to study this to understand this Newton's first law of motion. So we will discuss one real life example, and also I will teach you with the help of proof also. Now, all of you understand. For example, you all went to near one tree which is having so many fruits, flowers, and all. So you might be feel that experiment. You might be have been done in our daily life also. For example, I have one branch of tree. Imagine that when I'm trying to shake it vigorously to and from motion, you might be notice it. The leaves and the flowers and as well as fruits all will fall down. Yes or no, guys? Yes, please respond.
Yes, sir.
Why it will be happening? Why it will be happening? Anybody?
Gravitational force.
Because you are applying more inertia, sir.
Because of due to inertia. Do you understand what? Due to inertia. Now, let me take ready. This is the tree. Okay. Now it is having one branch. Is it okay, ready? This is having one branch. Understand, everyone? Yes, please respond. Now, Hari went here and he is standing here and he started shaking this branch to and from motion. Do you understand, everyone? So this branch of tree is started moving to and from motion continuously, vigorously. I am shaking. Then what will happen means, observe very carefully. I am not giving the force to leaves. I am not giving the force to fruits. I am giving force to whom, guys? I am giving force to whom?
Branches.
Branch. So branch is getting the energy. It is influencing by me. It is doing to and from motion. But still the leaves and fruits is trying to maintain its state of what? Still they maintain its state of what? Still maintain state of what? They maintain their state of rest. So that is why they will be easily detached from the branch and they will be fall down. Do you understand, everyone? Yes, please respond. Everyone?
Yes, sir.
That is what. So when I am trying to shake the branch, remains the leaves and fruits, they will be maintained state of what? They will be maintained state of what?
Rest.
Rest. Understanding? So when I shaken to and from motion, the leaves and fruits remains in state of rest or stationary. So due to their inertia, and they will be detached from the tree and they will be fall down. Is it okay, Hari? Have you understand? Yes or no? Everybody, please respond, guys. Now, while your mother, girls might be noticed, and of course, boys also. Nowadays, everything. Now, before Diwali and all, of course, even monthly once, 10 days, 15 days, our mother will hit the carpet with a stick. Do you remember, Reddy? Our side, Andhra will do bed and all. When we are keeping sunlight, we'll hit with a stick so that all the dust and all will go out. Do you remember? Everybody?
Yes, sir.
Yes, imagine. This is what the carpet. All of you should imagine. Now, what is the state of this one? What is the state of this one? What is the state of this one, guys? Rest. Yes or no?
Yes, sir.
Yes, everybody? Now you can see it is fully filled with the what? Dust particles. Yes or no? What our mother will do? Our bed also you can see. When we are hitting, what it is doing? It is doing which motion? To and fro motion. Yes or no, guys? Yes or no? It is moving to and fro motion. Dust particles are the carpet. This is what carpet. So carpet I am hitting with a stick. So that carpet is doing to and fro motion. But the particles which are present now, here it is having dust particle. So when I hit, the carpet will go back. But still the dust particle will try to maintain what state? Maintain what state?
State of rest.
That is what it will be maintaining a state of rest. Understanding? So a force of stick make the carpet to move to and fro motion. Understanding? But dust particles tends to remains in state of rest due to the inertia and they will be separate out from the carpet. Hope you are all very clear. Yes, guys? Understand this or no? So that is what will happen. So moves to and from motion slightly, but remains the dust particles try to maintain what? State of rest. Due to what? Due to what, Kaushik?
Inertia.
Due to inertia.
Inertia.
Inertia. What do you mean by inertia? It's an opposing property. It's a property of your body which will resist its change in state. That is what either rest or motion, which will resist. That is what we used to call as inertia. So that is why it is called as Newton's first law of motion. Also we can call it as what, guys? What we can call?
Galileo Law of
Inertia. Okay. So this is what about it. Now I will teach you real more examples. Let us take all of you. How many of you traveled in a car? Everyone? How many of you traveled in a car? Yes, please respond. Now you can see running a car or bus stops suddenly, then you can see even we people who even you are driving or you are sitting in a car or in bus, the passengers are jerked forward direction. Why, guys? Anybody can tell me? I will prove it now itself. Anybody? Why we all people will fall down? Suddenly that brake will apply. Your father or your brother or you yourself, when you apply the brakes, when you are keep on moving, suddenly you apply the brakes, our body will move forward. Anybody can tell me, please? Yes, please. Respond. Can I explain it, everyone? If you say yes, okay. Now I'm sitting in a driving seat. Okay. Now my car is running with the 80 km per hour. Now, if my car is running with 80 km per hour, my body speed also what, guys? What is my body speed?
80 km per hour.
Body is also 80 km per hour. Now, my which body is coming contact with the ground? Anybody can tell me which body is coming contact with the ground? Lower part. Yes or no? With the car base. Yes or no? Now, when I'm driving 80 km per hour, my full body speed is also what? What is my body speed? 80 km per hour. Do you understand? Now, when I apply the sudden brake, then immediately my lower part of the body will comes to rest. My lower part of the body will comes to what, Hari?
Rest.
Rest. Still my upper part is trying to in which motion? A state of rest or motion? Still
Motion.
motion. Do you understand? Still my body is trying to move forward. That is why our head will go and will hit to the steering or front seat or whatever it is. Do you understand what happened, all of you? So it will take time to get the action. Do you understand? So still my upper part of the body is trying to resist the change. That is only due to the what? Due to the
Inertia.
inertia. Understand, ready? Yes? That is what
Yes,
is
sir.
happening. Now, even I will show you the video also and I will explain you once the meeting is ending. Now, when we comes to the state of, suppose, bus is in bus bay or bus stand. Now, me, Hari, everybody, we all people boarding in the bus. Now we are all standing. No seat also. We are all standing. Okay. Now, driver is in bus. What is the state of bus now? Bus is in rest. Yes or no? It's not moving. Now, when we standing on the bus, what is the state of us also? We are in motion or we are in rest? When we are standing,
Yes, sir.
rest only. Yes or no, Hari? Yes. Go
Yes,
on.
sir.
Yes. Now, suddenly driver will start. We all people will fall backward. Why, guys? Anybody can tell me now? At least you can explain it now. Akilan, Mitakshri, why will fall down back? When the driver suddenly moves forward, why our head will go backward? That is what I want. Anyone? It's very simple, guys. Again,